You welcome to another episode of Black Guy Does Physics, where apparently around these parts, friction is the thing that causes wheels and disc and all of that to roll without slipping. Remember, if you need some sort of help, you have a question, comments, whatnot, leave it at the bottom. There's also a button that you could smash, and I think you should do like Hulk does and smash. Hey, don't smash your phone, but just smash the button itself. All right, let's get it cracking. Today we're going to be looking at Mechanics 2021, number 3, set 1. Once again, this is from my boy Spicy. Spicy been giving me a bunch of questions, and I'm trying to get at it. So then once again, there's going to be a lot bit more explaining than I usually do, but you could always just run this thing at like 1.5 speeds, man. Get what you need to get out of this junk. All right, so here we see, first thing we want to do all the time is that we want to look at the diagram that you see here, and then you try to figure out what's going on from the diagram itself. So I see some point, I see a rod. They gave me this thing here, which looks like lambda. Usually when I see lambda or whatnot, it's like a density or something. So this automatically indicates to me that I probably have to do some sort of I or whatnot. And this is a axis. It looks like an axis. Why would they put it there? So usually if I see an axis or something like that, some point like that on a rod, it would indicate that it's some torque thing. And you know, for torque is R perpendicular F, which is the same thing as F perpendicular R. And for calculus, it's like R cross F or something like that. But with torque, you should also automatically know that forces come into play, and that is F net is equals to MA, which means that you have to break down F net X is equals to MAX, F net Y is equals to MAY, and go from there. So that's what pops up in my head. It's torque and forces. Or you have to calculate some moment of inertia or something. That's what should pop up in your head also. So let's read. Triangle rod of length L, mass M, has a non-uniform linear mass density. There we go. By the equation, lambda equals to, I think that's a gamma x squared, whatever it is, where gamma is that. Oh, Lord, sweet Jesus. And x is the distance between the point P and the left end of the thing. So x. So x goes from 0 to L. Cool. So definitely some integration going to be popping off. Oh, look at this. Using integral calculus, show that the rotational inertia of the rod about the perpendicular axis is this. So they're giving you your answer and they want you to prove it. So I made a copy of this, put it over here so we could do some work on the side here. I was going to put that in black. Let's put that. Nah, red is going to look too hideous. Let's go with blue, I guess. All right. So whenever they're asking you for the moment of inertia, you have to know what the equation for the moment of inertia is. The equation for the moment of inertia is that it's equal to R squared dm. That's the answer. End of story. Next problem. Nah, but really that is the answer. But the problem that you have here is that this integral sign, when you're integrating, you're summing over this thing. And the thing here, this R will be changing. You see what I'm saying? So because the R is changing, but you're summing over the mass, this can't be done in its present form, which means that you have to find some way to either rewrite R in terms of M or M in terms of R, so that you could get whatever is changing and the thing you're summing over to be the same. You see what I'm saying? So the basic essence that runs with is that you have the density of something. You have 3 different types of density. You have the linear mass density, which is M over L. You have the, what is this? The surface charge density, which is M over A, or the surface density, mass surface density, or whatever you want to call it. And then you have the volume density, which most people understand is M over V, right? So you have to get one of these. That's usually. In an AP class or test, they don't usually do this one. They don't usually, because this one becomes very tricky because this is 3 dimensions. This one is 2 dimensions because it's length times length. This one is just 1 dimension. This one is 3 dimensions, which is length times length times length. So you usually have to do like 2 different steps of integration to get to it. And on a test, you're not going to have time for that. So you don't have to usually worry about this. This one maybe. This one definitely, as the question would say just now. So let me just move this over a little bit and whatnot. So if we're looking at this one, which is saying that lambda is equals to m over L, right? Then I could see that I could rewrite this as, if I have lambda is equals to m over L, then I could rewrite this as lambda L, I'll put a little l or big L, because they use big L, whatever, is equals to m, right? Now, lambda is a constant because that's the density. The density doesn't change. So what I could do is now is just take the small whatever of both sides, or I think what I should have done, forgive me, since the density doesn't change, I could say a small m and a small l, that ratio is still lambda, since the density doesn't change. You see what I'm saying? So if I chop out a small piece of this, an extremely small piece, because that's what dm means, small mass, I took a small mass dm, then what I'm saying, dm, that mass over that length, which is dl, should equals to lambda still because it's constant. Then if that's the case, what you have now is that you're going to have dm is now being equal to lambda over dl. So I'm saying, so now you could substitute that into that junk over here. So your I now becomes r squared lambda dl. And this always works for whenever you're talking about linear mass density. So now you could see from this crap here that this is r and this is l, but have no fear, because the r represents the distance you're talking about this, and in this case this is 0, this is x. So I could write this as x, I could rewrite this as x squared lambda, and since we're talking about the total length, right, dl is a small part of it, that would just be dx, because you can see that x is going to be written from like 0 to L. You know what I'm saying? So now when you have that, because they gave you what lambda is here, they told you what lambda is, you have to insert what lambda is. And what the hell is it? It's x squared, what the frick is lambda? Gamma x squared dx. Oh, that's not cool. All right, cool. See that? So, and then they put what gamma is, but you can see that gamma is like 3m over L cubed, right? M is a constant, L is a constant, so you don't have to worry about it. You could put it in at the end, that's fine, or you could insert it as quickly as you want, whatever the case is. That's a constant, this is a constant, so you could move it out. So that would be gamma, which is 3m over L cubed, integral of x to the fourth dx. And now since you're integrating it, you must have some limits, because as you could see, we're trying to start from here to here. So since we're starting from here to here, then the limits must be from x is equal to 0 to x is equals to L. So that's my limits, from 0 to L. So I integrate this bad boy. Hopefully my integration doesn't suck. So I think you add 1 to there and divide by it. So I think it's like x to the 5 divided by 5, I think. And then from 0 to L. I think that's what happens. I think. Don't judge me if I can't integrate. Okay. And then you just plug this stuff in, right? When you put, so x where x is 0, it would be the top value when you plug this in minus the bottom value, right? So when x is 0, this whole thing becomes 0. So you don't have to worry about the 0 part. So now you have to put in when x is equals to L. So when x is equals to L, I'll have 3m over L cubed times L to the 5th over 5. And I think I could do this. That would give me 3 over 5 m L squared. And I think that's what they ask us to do. Let's go! Clutch. So you see how it works. So if you didn't catch what I just said, just replay the video and you'd see that. And play it at a slower speed. You'll see what I did with the math and everything. That's a good thing about having this video. You could actually watch it over. So if you didn't catch anything. And then if there's something specific you want to ask, just leave a comment in the bottom. So we're done with part A. Let's see part B. Determine the horizontal location of the center of mass of that. So I probably would have to add another another sheet of paper, which I should have done before. Look at me not being prepared. It's like I don't even have a YouTube channel. Shaking my head, silly rabbit. So, what do you need to know for x of c or xcm? It's the same junk as you just did. Xcm, I think, is just the integral of, what is it? And the integral of dm, it's what? X, it's dx over dm or something like that. I can't remember totally. So, what happens is that the dm becomes the integral. It's not x, it's, is it x dm? Is it x dx? I can't remember. Oh Lord. I know that this becomes m and this becomes